Hey guys, welcome to the 6th lecture of ATS 211. Last time we met, we just met on Skype and we kind of made everybody's accounts all get set up, and we did make sure that the X11 connections were working. Remember, that's the communication standard between my server and your laptop that gives them the ability to get two-way communication about graphics. That's how the graphic instructions from Chesapeake end up on your screen rather than on Chesapeake's screen, which wouldn't be very useful to you. Meanwhile, how your mouse commands and things like that are ending up understanding how to affect things over on Chesapeake. X11 is a very old standard, but it is how things like that are done. Anyway, we had to make sure that all that X11 stuff was working, and we tested it with XIs, and we set your password and stuff like that, but it was pretty straightforward stuff. Did a little bit of playing around with a little bit of writing scripts as well. We had your, we messed around with what I think was sat job and surface job, I think was the two we were messing around with. They were just little scripts. I wrote them, and they're just one line. A script is something like a program. It's more like it's something that kind of automates calling other programs or invoking other programs or whatever. But we started to see how you could edit those programs using a text editor. I showed you Nano just because it's, well, very simple. Okay, there was basically no learning curve to Nano. Nano is by far not my favorite way of making a file in a Unix or Linux environment, the way Chesapeake is, but these programs that we're making are only a line or two long. It's just not that big of a deal. So rather than take time to learn a better text editor, Nano will be fine for like a 2-line program. We started to see some of the things you could do with WXP. We started seeing some satellite pictures. We started seeing some surface weather plots, etc. Well, let's build on that. Let's start seeing some of the things that we could do with WXP that would be, well, it's increasingly clear how this would be a useful thing. Now, keep in mind, like I said before, WXP is a commercial product. It is a commercial product that has largely been outcompeted, as it happens, by other products that are used by the Weather Service and airlines and power companies and so on, although WXP still has a slice of the market. There's no doubt about it. I happen to know a lot about WXP just because it was developed at Purdue University in the Atmospheric Sciences department during the time that I was a student there. So like I knew the team who was involved in writing it and so on, and I did a lot of testing of it for them and so on. But anyway, at some point it got spun up, and then it got bought as a company, and then it got bought by another company, which got bought by another company, and as such things happen, okay? So WXP itself is unlikely to be what you would encounter in a workplace, like if you worked for a power company and they're forecasting, or if you worked for an airline, but it is functionally similar, okay? I mean, the commands will be slightly different than this, but they'll be the same idea. You know, there'll be a slightly different command that makes a surface plot, and it'll have slightly different ways of controlling the contours and so on. But the idea is the same, and that's why we're doing this. Okay, now how do we actually control what a Linux command is doing? Remember, Linux is the operating system we're using. Unix and Linux are kind of, you could think of them as being interchangeable names for this kind of operating system. It's not Windows, it's not Mac. Because one of the main things that's different is that Windows uses Windows and Mac use a graphical user interface, a GUI, G-U-I, GUI, whereas Unix, Linux computers are fundamentally driven by the command line interface. You type commands in. Now, if you're actually sitting in front of the server like I am, I could actually bring up in this window behind this monitor behind here, that's actually Chesapeake's monitor, and I can use the mouse and so on, but that's not in general what you do with a Linux computer. In general, you are remote from it, and you use these command lines to make things happen. And in general, the way you make a command happen on these kind of Linux, Unix type systems is you just type the name of the program you want to run. Password, P-A-S-S-W-D, is a program. Somebody wrote password. And when you invoke that command by typing P-A-S-S-W-D, what it does is Chesapeake figures out where that is on the computer's hard drive and then executes that program. Okay? In much the same way that, like on a PC or a Mac, you would click on an icon or something like that. Exit, believe it or not, is a program. Okay, somebody wrote exit, and it does something to like shut down your connection and so on. We briefly saw that command ls last time. Ls is like the make a list of the files. Okay, it just kind of scrolls to the screen the files that are in the current folder that you're in. They don't use the word folder in Linux; they call it a directory. But okay, these are a few of the many, more or less infinite number of these kind of commands, which are really just a program. Which, by the way, is what's really going on your Mac or your PC as well. I mean, when you double-click on an icon to make something happen, what you're really doing is launching a program. Somebody wrote a program that does whatever it is you just clicked on, okay? It's just, instead of clicking on it, you're typing its name here. These kind of commands are verbs. We talked briefly about we get more into this in ATS 3.15, but commands that you launch on a computer are verbs. They are an action. You're going to change your password, or you're going to copy a file, or you're going to print something, or you're going to launch some program, or ls, to list the contents of the file. And you can modify what those programs do. You can kind of think of these things as being like adverbs or something like that change what the program does. The right word for them, though, is flags. And I have no idea why they got this name, flags. But flags usually start with minus, and then they have something. Like the ls command can be modified using minus last. I don't know. Last stands for something. I can't remember what it does. I don't remember the name. But I'll show you that if you just type ls, like I happen to be in this window here, I was logged into WXP, and I was in a folder called etc. You can see that actually from like the command prompt and so on. And I typed ls, and I just got a list of all the files that were in that directory. Or I could type ls minus last, and minus last gives you like the details of the files. This is very similar to like in Windows if you are in your File Explorer and you choose the view of details, where you get to see things like the file size and its creation date, and who's the owner of the files and who created the file, and like these minus R, minus W's, these things are all about who has read and write permission to those files and so on. It's a different way of viewing them. I have modified the ls command using the I've modified ls using the minus last command that just gives me all the details. And again, last stands for something, I can't remember. The L stands for long. I don't remember what the rest stands for. We could Google it and find out, but it doesn't matter. But see how I modified I'm still using ls. I just modified its behavior. Well, like in this case, that minus last is just sort of a flag. It just switches on a behavior. Okay, there are different behaviors the ls command can have, and we turned on the feature last to get the long, asynchronous, standard something. I don't remember what it last stands for. Anyway, that's a thing. And there are lots of these kinds of flags that you use when you're making a program. Just as an example, if you guys are one of those survivors of ATS 3.15 from a couple semesters ago, you might remember when we compiled programs, we had GCC was our command, and then there was a minus LM that was to link to the math library. Okay, minus LM meant that we wanted to connect it to the library of mathematical tools. That's all it does. It just turned on a feature. We turned on something like link to the math libraries. Okay, but other of these flags are set up to actually set a value of a variable that's inside the program. So for example, here I'm going to be using the satplot command. You might remember satplot is a WXP command. Since I have WXP installed here on Chesapeake, I have WXP installed on there. Therefore, we can now run the WXP commands, one of which is satplot. And for example, when we were messing around last time, we just wanted to change the domain of a plot, like, spatially where it was, and that flag was minus PD equals, where PD stands for plot domain, okay? And we're passing it the value MW. Literally what's happening is the letters MW are going into a variable inside of the program satplot. Now, how would you know to do that? We're going to have to find some documentation. Okay, you couldn't guess, right? There would be no way to guess that the variable's name is that the flag we would need to set is PD for plot domain, and you couldn't have guessed that it's MW versus Midwest or MWest or who knows, right? You have to have documentation about these kind of things. But this was a trick we actually did back in the 5th lecture. Was we actually set the plot domain to different regions just to try it. Now, so like for example here I'm building a command. This was actually cut and paste from the command that we were building back in Lecture 5 when we were together on Skype. And so we were saying that we used sat plot, and we were saying minus PD equals SE. We just tried it, and it was SE, I happen to know, was the code for Southeastern United States. So minus PD equals SE changed it so that instead of getting the satellite from view of like the whole disk of the Earth, as viewed from the satellite, we just got a zoomed in area around the Southeastern United States. All right. In this particular case, we actually get a second example of that, and that is that minus IN flag. Here we are setting minus IN equaled area. Minus IN happens to be the flag that controls the input format of the file. See, we have a file here that we're going to be loading. The file is /home. It's in the folder called home. It's in the, everybody inside of home has their own, including you. I happen to be logged in here as WXP. And so in the home folder, WXP, in the folder that's that 2003 February folder, it was filed for 03020718, and then it's satellite visible east.mca. And that .mca file happens to be a Macitus area file. Macitus is the satellite software and such that comes from the University of Wisconsin. It's nice stuff. And it's a common file format used in remote sensing and satellite meteorology and so on. I don't know anything about what a Macitus area file all has, other than it is the format of like satellite files that are transmitted over the internet from one school to another and so on. There are other satellite formats. If you actually later go look at the documentation for SatPlot, you'll see that there's Genie files and 2 or 3 others that are used. As it happens, this is a Macitus area file, and SatPlot needed to know that. So I set minus IN equals area. Again, I'll show you where the documentation is. But with that information, then, it knew to expect this to be an area file. That's kind of like if you had to, like if you double-click on an icon of a file that somebody sends you on your Windows computer or your Mac, well, that file might have been a GIF file, it might have been a JPEG, might have been a PDF, who knows, right? Well, on your Mac or your PC, someplace there's a table that contains information about what program to use to open different files. If it's a .docx file, then you're supposed to use Word to open it. If it's a .jpeg, you probably have some kind of file image viewer. If it's a .pdf file, it's going to open it using something like Adobe Reader or Foxit Reader or something. That doesn't exist in Linux, okay? We have this idea that there's like a table that tells it how to open different kinds of files. We have to actually tell it. So in this case, we're telling it minus IN equals area to tell it that it's an area file. Okay, whatever. It's a Macitus area file. All right, what else we got here? That region code that we used minus plot domain, minus PD equals, WXP provides a huge list of these kinds of codes. And for example, we could use US for United States or USE for an extended, kind of extends out into the oceans a little bit. EUS for Eastern United States, there's NE for New England, AT for the Atlantic, SE for Southwest, all the way through here, Northwestern, Southwestern, etc. NB, strangely, for Nebraska. But there are maybe 100 of these domains already defined. And actually, it's not that big of a deal to add more to that, but I'll show you that in just a little second here. Hey, the story here of NB being Nebraska is kind of an interesting story. It has to be NB because NE is already New England. But all the states have a code like that. I tell you an interesting story. So when I moved to Indiana, I had to get my driver's license changed from Nebraska to Indiana. And when I went to the Department of Motor Vehicles, they punched it all in and they squinted at the screen and they punched it in again and they squinted at the screen and then they called the supervisor over and they stared at the screen. And then a state patrol officer came over and stared at the screen and gave me a scary look. And they came up that there was no such person, this was a fraudulent driver's license, etc. And it was because they were punching in NB for Nebraska instead of NE. And on their system, NB was New Brunswick, and they, like in Canada. And it turns out they have a sharing mechanism, Indiana State Patrol or something. It can pull up the databases in New Brunswick. And it was coming up that there was no such person, and this was a fraudulent driver's license, and so on. Once we got that sorted out, Mr. State Patrol Officer was much less stressed. Anyway, okay, so NB is Nebraska or whatever. And there are all these codes are actually defined in a file that you should be able to actually go look at if you want to. It's, you know, you could use Nano or something like that to go and look at home WXP etc wxp.reg, where this is a table of WXP regions, and I just have a screen capture of part of it there, but you can see it defines the US is a contiguous US view, and then there's some coordinates there that actually are used by the map projection software to figure out where is this region we're calling US. So where is this region called Southwest? Where is this region called Central Plains, etc.? So like Central Plains, 37, negative 95, 1.1. I think the 37 is latitude, the negative 95 is longitude, where negative is to the west, and 1.1 is a scale factor as to how big of the region is, but whatever, it's all defined someplace. But anyway, there's tons of these, probably 100 of them, maybe even more, all in that WXP reach file. And for that matter, if there's a region you like and you're interested in, we can add it. If you are from Botswana and you want to add a Botswana code here, you want minus PD equals BOT to be Botswana, if there isn't already a Botswana, we can add it. Okay, that's the beauty of all of this here. By the way, you can also define your own regions. For example, the most common way to do it would be to have a region centered on a particular station. I mean, now here I'm using, by the way, a new program, Matplot. Okay, Matplot just makes maps. I didn't feel like having weather information plotted on here. So like Matplot minus PD equals, and then ID colon and a weather station I wanted, made it centered on that station. So like KOMA is Omaha Epley Airfield, and we're now centered on Omaha Epley Airfield on this little map right here. And we can actually add it with a comma and then a number that is sort of a scale factor. Now that probably takes more just kind of trial and error to decide what you like there. Here I've made it 0.5, and you can see we're more zoomed in on Omaha. Or here I changed it to 2.0, and it's more zoomed back. Okay, that number means something. It's hundreds of kilometers in every 1/25th of the way across the screen or something. It's odd how it's defined. It's more just do some trial and error and figure out what those numbers means. You know, if you wanted to experiment with that. And again, you could make it centered on your hometown, you could do whatever. I mean, as long as you know the 4-digit code, and if you don't know the 4-digit code, please let me know and I can get you that station identifier. Alright, so this is another way you could have a custom region based on, you know, centered on your hometown or whatever. Alright, let's talk about the different ways we could actually put weather information on a weather map. For example, let's just plot temperature for a little bit. So here's a command that could be part of like a little script that I had written, where I said surface plot minus PD equals MW. You can see I have a Midwestern map here. Minus VA equals temp, because the variable that I'm plotting is temperature. And then that's the name of the file that we're plotting again. Again, this is still that 2003 data. I'm still in the process of installing the software and stuff to get operational current data. So until that time, we're just going to mess with this old case study stuff that happened to be on a disk. Okay. So the variable that you're plotting is going to, of course, be with the minus VA flag, where temp, in this case, is the code for temperature, and I'll show you some more different variables in a little bit, but if we just give it that information, and there's no other flags to modify the behavior of surface plot, what surface plot is going to do is it's going to plot just temperatures on the map. In practice, it's going to only plot some of the stations on the map, by the way. It's only going to be plotting, survivors of ATS 315 know about this, priority 3 and higher weather stations. Okay, if you actually plotted every weather station, you might remember there's like 40-some in Nebraska alone, it would just be too cluttered and hard to read. So it's only plotting one so that they're not too crowded. It's only plotting a selected group of them. Okay, so it's just going to plot the stations on there if you don't tell it anything. But we can change what it's going to do using this minus PL flag, where PL stands for plot type. Well, again, you would never have guessed. I'm going to have to show you where there's documentation about all of this. But if I set PL equals value, it will actually change that to, it has converted those observations that were at stations to a grid. Okay? It is interpolated. It's actually used objective analysis, to use a terminology from ATS 315, to kind of come up with what the temperature would be at each of those grid points, where they're just sort of in rows and columns like that. By the way, notice the fancy schmancy thing I did here just to illustrate. See how my command here, it wouldn't have all fit in this little space here, so I use that backslash. Okay, that means I continue the next line as if it's part of this line. Remember, we have to do that because Linux is actually strangely stupid about the length of the line in these commands, okay? And Nano, in particular, is really stupid about it. And so once you get as wide as the screen, just use that slash and move on to the next line. You know, hit enter to move on to the next line or whatever. Because that backslash, actually, it's not a slash. Because Linux just is weird about that, okay? It still thinks in terms of things like punched cards and so on. It's not literally thinking in terms of punch cards. It's more a matter of the file standards about these things are set up already thinking 80 characters wide. Okay, so it might be a little weird as to why you would think that would be value. PL equals value to get these gridded values. Value is actually an abbreviation for gridded value. Anyway, you get these kind of grids there. But you could set that minus PL flag to LN, where LN is WXP's little code that means line contour. Okay? And you get a map more like that one up there where it's the same information. It's just now presented in the form of line contours like what you would draw with your hand. Now you can decide for yourself what you think of that particular plot and is it ugly or is it pretty and all that kind of good stuff. You know, meteorologically it's certainly useful. Okay. Again, if at your first job you're using NA whips instead of WXP, it's going to be the same sort of thing. Instead of PL equals LN, it's going to be, I don't know, minus plot equals line or something like that, but who cares? It's going to be the same. If you can solve this, you can solve that. Okay? We're learning in how to learn, not necessarily memorizing WXP commands. I mean, that'll be fun for this class, but isn't necessarily where we're going like with your future. Nobody loves line contours. I mean, well, they're not everyone's favorite way of doing things. You want to switch it to color-filled contours, then just change minus PL equals CF, where CF, again, is the code for color-filled contours, and you'll get a plot something like this little one I have up here. And it's, again, the same exact weather information. I haven't changed the time or anything like that I'm plotting. I'm still plotting temperature, etc. It's just that we've seen now several different ways to visualize the same information. Okay, that's going to be a powerful tool as we start talking about like analyzing weather patterns and so on. Okay, now WXP makes a valiant effort to try to figure out what's an appropriate contour interval to use. Should I be drawing those temperature contours, those isotherms, every 5 degrees, every 3 degrees, every 1 degree? But you know what? Sometimes that's just not what you were looking for. So feel free to use the minus CI equals, and then a number to tell it what the contour interval should be. So minus contour interval equals 1, well now it's drawing a contour every 1 degree, so I can't even read it, it's too small on there. But you know, let's say that's 20 and 21, 22, 23, 24, all the way up to whatever we need. And yeah, it starts looking a little bit like a fingerprint with all these swirls around and so on in it, but it's contours at a new contour interval. And that same flag, by the way, minus CI equals, works just fine for the color-filled contours as well. If you want the little regions of each color to be smaller, by all means, just set the contour interval to, you know, so I've got I didn't change it on here. So the PL equals CF here on this command here, and contour interval is equal to 1. Now, you might notice here that we've got something kind of unexpected. I mean, if you look at that map that we got there, you might be kind of surprised if this is a map of temperature, that it's colder in, say, Tennessee than it is in, say, Iowa. Okay, well, that's not meteorologically impossible. That seems odd. And of course, we didn't notice that being the case on any of those other plots we have. And if I zoom in a little bit closely, I can see that there was a problem. If I actually look at the little numbers that are on some of these contours right here, like I can see up in South Dakota, it's like 14, that's the 18 contour, and in Iowa it's about 30, but if I go down here to like Tennessee, it's like 40, 42. How come we are using that same shade of blue? I mean, that same shade of blue that's 42 degrees in Tennessee is the same shade as 18 degrees in Minnesota. What's going on here? Well, the answer is that there is a table of these colors that WXP is using, and this is some kind of like rainbow color table or something like that, that has, you know, maybe, I don't know, 20 colors in it or something that's specified from like purple to blue to light blue to green to yellow to orange to red. And if we need more colors than that, like if we get to red and we still need to keep drawing more colors, it just reuses them. So once we got past red, we went back to purples and blues and stuff, and so the same color means 2 different temperatures. That's why it's awfully helpful when anytime you're making something that involves color fills to include the minus PA equals bar command. So like look at this plot here. Surface plot minus PD equals Midwest minus PL equals CF for color fill contours. The variable's temperature. The contour interval is 1. And minus PA equals bar. PA is like plot parameter or something like that. I don't remember. But that will put that color bar down there at the bottom. That's something of a key to how the plot works. And you can see that like the darkest purple is 8 degrees Fahrenheit. And like the bright blue is about 19 Fahrenheit. And the red is like 29 Fahrenheit. And the, oh wait, we get to that blue purple again and it's 35. See how you can tell the colors had to be reused? Okay, that's bad form. You don't in general want that to happen. So, okay, our contour interval of 1 is apparently too small of a contour interval, and we end up having too many color fills here for this color table. By default, it's using a standard color table, rainbow.color or something like that. There's a whole mess of these different color tables. Some of them have more colors in them, some have fewer colors. WXP by default uses, I believe it's rainbow.color. But anyway, that can be changed. We could choose a whole new color scheme and make something different, but you know, another simpler solution is just to come up with a wider contour interval. So here I made that same exact command run, but I set the contour interval to 2 instead of to 1. And you can see how now, if you look at the bar, 8 degrees is that dark purple, and 28 degrees is that bright blue, and then the yellows hit 40 degrees, and then the orange hits 44, and we have a much more logical map here. Okay, we now have a map that just spans the colors one time, and we don't cycle through the colors multiple times. That's good. That's much better form. Okay, now on something like this map of temperature, my guess is we could have made sense of it. Okay, we wouldn't really have to have had that great sense. But that being said, there are other parameters that we use in meteorology that could have become a real mess. Quantities like vorticity and divergence, which depending on what classes you've had, you may know more or less about, but they're numbers. Okay? We think of vorticity as like the spin of the wind, but vorticity is a number that describes the rotation of the wind as well as other factors. Divergence, we think of it as being like how the air comes together or goes apart, but it's a number that's describing how much the air is coming together or going apart. Those numbers can range over multiple orders of magnitude. You have to be really careful as to how you contour them, because like if the colors are cycling, and purple can mean several different colors, purple can mean several different values of vorticity. I don't have an intuitive sense when I look at that map. Oh, that's this area of vorticity. It's around this value of 5 times 10 to the negative 6th, not this area over here of 1.1 times 10 to the 4th. You know, no, who knows, right? So you have to be really careful. That's why having that bar on there to help you make sure that you're not cycling through the colors multiple times based on your current contour interval makes good sense. Turns out there's going to be other things when we get to animation that's going to make that bar a necessary thing. We're not doing animation yet today, but we will get there. Alright. Everything that we've looked at so far was temperature, but obviously we can plot lots of different things depending on what variable you want to plot. Clearly, WXP provides a whole bunch of other codes that can be used with the minus VA equals flag to plot different stuff. And these internal variables that are built into WXP are summarized on a web page that I'm going to be sending you. Now, I mean, if you look at here, the code, you can get temp, well, for that matter, city, that's pretty slick. You can actually get a map of the station identifiers. The temp for temperature, dupe for dew point, wind direction, wind speed, press, P-R-E-S is a good one to know for pressure, for sea level pressure. A lot of these are fancy stuff that we're not using in the context of this class. Either they don't apply to what we're doing, or we don't have the right data sets. Like some of these are for models and stuff like that. Like for example, grid relative U-wind component and no, that's a modeling thing. Let's not worry about that. Seems like there's a bunch of geostrophic stuff in here and so on. That's model stuff. We're not worried about that right now. And again, that table scrolls on. I mean, there's a whole bunch of like derived properties that aren't necessarily in the report, but can be computed from the report. I mean, the report that are in those METAR codes that got decoded don't include things like relative humidity, but the relative humidity can be computed from the temperature and the dew point, so we can get RHUM, which is relative humidity. And so we could set the variable VA equals RHUM, and we would have a map of relative humidity, or wet bulb temperature, or mixing ratio, or humiditure, or heat index, or wind chill, or, oh my gosh, all over the place. All these things that can be computed that are built in. By the way, there's also a whole way to add your own. I mean, if one of you guys came up with something you wanted to plot, as long as it was something we could get from METAR observations, you know, some kind of calculation, we could build that in too. That's not a terribly difficult thing to do, although I don't think that in the context of this course we're going to hit that. I don't think that we're going to think of things that are not already built into WXP, but like, it can be done, okay? Just to give a sense, survivors of dynamic meteorology, I think Mike might be the only one, like the terms of the Zwack-Akasi equation. Okay, this is a way of making forecasts of cyclogenesis, the development of cyclones. And there's various terms in it, like stretching and tilting and differential vorticity advection and things like that. Well, you could add all those. Okay, they're not built into WXP, but they can be programmed. It's not simple, but it can be done. Okay. Where's Dr. Shruggy getting all this information? I mean, you kind of could see there that I was clearly just showing you screen captures from a website. Where was that? Okay, well, of course there's a website that runs it, but strangely, WXP's website is really hard to find. You might have noticed that the URLs that were at the top of the page when I was showing you those screenshots of the WXP website, it wasn't like it was WXP.com or something like that. It was just a dotted quad IP address. It's like 167 dot something or other. Okay, hard to find. Okay, I don't know why it's kind of buried like that, but I can give you a little shortcut. I used bitdo, which is a URL shortener, and created bitdo/WXP6. And so anytime you need to go to the WXP documentation, just point your browser to bit.do/WXP6. I know that's not simple to remember, but it's a whole lot easier to remember than 167.191. whatever it is, okay? Alright, I don't know why the documentation is hard to find. I think maybe it has something to do with the way the commercial licenses work for the software. Whatever. We cheated. We have now a handy little way to find it. And so if you pull up that bit.do/WXP6, because this is version 6 of WXP we're using, you get a page that happens to look just like this. And again, you can see the address is horrible. 136.61.121.32. I mean, we don't need to worry about it, okay? And then here is actually, that points you to the program reference, which is this list of all these things that are part of WXP. A lot of which we are not going to get to in this class, but we are going to be doing a lot of things like plotting. And so, for example, you might see on this page here, map plot is on here, which is just for making maps themselves. But like, for example, if we scroll down farther, there's things like sat plot for making satellite images and surface plot. And you'll see that there's going to be other ones that we're going to be using as well. Not all of these yet work on Chesapeake. I only kind of did a partial installation just because there was the full thing would like fill my hard drive. But anyway, alright, so there's all kinds of good stuff there. Alright, and if you follow the link for something like surface plot or whatever, you'll get a page that you can see it says here, surface plot, that actually gives you the documentation as to what all surface plot can do. And it can be a little bit cryptic. You can see there's a whole bunch of lists of like these kinds of flags, like -ME equals and then a level. This is the message level. My experiences in WXP, not all these message levels work, but it can give you like information to help you know what's going on in the program. Like if you set message level equal to something, it'll tell you what it's doing, like it'll print debugging information and so on, but you don't really need any of that. That's though where you can find all the parameters about like the different variables to plot, or the contour interval, or the colors, or whatever. It's all documented in there. Okay. That being said, I'll also be teaching all those kinds of things to help you so that you can do weather briefings and so on. But the parameters are all there. You know, bookmark the site. You'll find that useful. Similarly, like there, you could click on the page for SATplot and learn all about the different things that SATplot can do, and all the different default files, and all the different data paths, and all the different projections, and all the different color schemes, because you usually use a slightly different shades of gray for like visible satellite images than you do for infrared satellite pictures. I mean, there's a whole universe of this stuff, okay? And again, yeah, your first job you're going to be using something different, almost certainly. So what? It's all going to work the same sort of way. I mean, there's going to be flags that set, or, you know, or whatever set these different features, okay? It just this happens to be the software we have access to. All right, fantastic. Now, once you actually have this in hand, an awful lot of really fancy schmancy stuff is possible. Now, so far I've only shown you surface data, but obviously we can do all kinds of fancy things, but we can even get fancier about how we do the analysis. I mean, for example, look at this plot here. Now, I personally think this particular plot's a little bit on the ugly side, but it has two different types of weather information on it. It's an overlay plot. It's got colors that represent the temperature, and it's got overlaid on top of that white contours of pressure. Now, depending on what you know about weather analysis and forecasting, you may or may not know that there's all kinds of things we can learn about, like air masses from this kind of information, or areas of warm air advection and cold air advection, all of which we're going to get to, okay? But you can probably think of weather websites you go to where they have plots that look like this, where there's two types of information on top of each other. That's called an overlay. In this case, it just happens to be sea level pressure and surface temperature. Wow. We could do all kinds of groovy stuff, all right, like overlays. And for that matter, maybe you don't want your plot in millibars, or you might notice there that it specifically says sea level pressure in millibars and surface temperature in Fahrenheit. Maybe you want your map in Celsius, or maybe you want I don't know. Okay, we can do that. We can change the units. I bet you really wish we could animate these things. Okay, we're several steps away from animating, but we'll get there. This is surface data. You probably are thinking at some point, if we're going to be doing forecasting, surface data is nice, but we're going to need upper air data as well. We're going to need to be able to look at things like troughs and ridges in the jet stream and areas of positive and negative vorticity advection and all the kinds of stuff that you need in order to make a forecast. Yeah, we're heading there. We're going to be able to get all that stuff. And for that matter, everything that we've seen so far is some kind of observation, whether it was satellite data or whether it was, like the surface observations and sooner or later the upper air observations. But what about models? I mean, we're going to be able to need to be able to visualize what the models are doing. We're going to be able to look at the forecasts that come from them and see how the weather patterns evolve and so on. Yep, well, that particular part I don't have working yet because I don't yet have the data feed where it's bringing the models in to Chesapeake. But I will. It's going to get there. All these things take time. And this is all great. Oh my gosh, let's do it all now. Let's do it all right now. No. Patience, grasshopper. We need to actually build our skills first, okay? So, what I want you to do is you're going to be trying to work on how to make these skills work before we start building into fancier and fancier things. You gotta walk before you can run. So what we're going to do is before our Tuesday's class, I want you to spend more time working on just making some basic plots, okay? There's no explicit assignment. I'm not yet going to tell you make this plot and show it to me, because here's the deal. I know from experience, the first couple times you do it, it isn't going to work. There's going to be problems. You're going to break your scripts. You're going to not know what's going on. Something's going to have happened, and that's good. That's called learning, okay? If you don't break things, if you don't find yourself not sure what went wrong and now your plots are blank or something like that, I know that means you didn't do it, okay? Well, maybe you're perfect the first time, but I kind of doubt it, okay? So for now, just get more experience working with the scripts that we've been doing and editing them and making changes to them. Try different times, different plot domains, different variables, different contour intervals. Switch back and forth between values or contours or color fills. Experiment. Start seeing what you can do with this before you get an explicit assignment on Tuesday's class. Okay, well, I think that's all I wanted to tell you in this extra lecture here, and I will look forward to seeing you on Tuesday. Between now and then, break it. Let's find some way to... I'm looking forward to seeing the creative errors that you get. All right, let me know if you have any questions.